Okay, recording has begun. This is Bioinformatics Data Skills. This is your last chance to escape the hellscape that awaits you. You ready? All right. I stuck it up on our general channel, the first chapter of this book, but you need to go ahead and order this ASAP. We're not going to be doing every chapter in here, so don't be too afraid. It's a thick one. But we will be going through a lot of the book. The way this is kind of set up is inspired by this book. I kind of wanted to make the bioinformatics class that I wish that I had taken first. And so that's the class I've tried to make. That being not learning specific software, not trying to become a computer programmer, but just learning those like kind of data and command line soft skills that let you kind of drop into any bioinformatics software, figure it out, and get some answers. And so that's what we're trying to accomplish here, with the other goal of everything we do being highly reproducible. Okay, so that's one of the major advantages of using code to kind of look at your data, is that you got a fossil record of how you went from raw data to your analyses, and that helps you find mistakes. It helps other people find mistakes in your work. All right, so get that book, read through it. But in addition to that, we've got a website, and I sent you a link to that as well. Let me pull it up here, and I'll share my screen. All right, is that showing up? Yes, all right. So go ahead and bookmark this. It's going to be kind of our one-stop shopping repository for things related to this course. It's broken down into weekly chunks, and it's got your assignments for the week, some resources that I put there for a reason. Don't ignore those. Usually it's just like short YouTube videos or something that kind of help explain some of the trickier steps that we're talking about. Some practice stuff. All right. So we also have a shared course notes that we can all it's just a Google Doc that we can all add to. I think that link is broken right now, so I need to fix that. And here's your syllabus. Okay, so it goes over the topics we'll cover, free advice, and then what everyone cares about, the grading scale. Okay, this is it. We've got 10 assignments and 4 case studies. No exams, yada yada. All right, so all of your points are based on these. They are all open note, open internet. You can work with a partner on them. In fact, I'd encourage you to work with a partner on the case studies because they're just a bit more complicated. Okay. But that's what we got. You'll have a week to get each one done. Case studies may go a bit longer, especially towards the end. Our kind of final project in here will be case study number 4, and we're going to take an entire Illumina sequencing run and assemble a metagenome. That's probably going to take more than a week. All right, so we can be working on that for a while. It's all right. Okay. And still haven't fleshed this out because I got busy working on the website and forgot. Okay. So go to the website for our weekly schedule. Okay. So I would like to hear from you briefly. Why are you in this class? I love to be interrupted, by the way, so you can just start shouting. It's fine.
Because you told me to take it.
Ah, there we go. An honest answer. Okay.
I'm in here because I'm a
bio major, so it's just part of a requirement.
Is it? It's not a required course.
Or not a requirement, but it just like works well for my schedule, gets me an upper division class. So,
Okay.
yeah.
Well, you're in for a treat. Let me tell you. It's probably going to be unlike any biology class anyone's taken. That's for sure. We're going to be working with DNA data, the real raw stuff, right? You hear about DNA sequencing. This is where you learn how to actually take that sequence data and use it. But we're not going to be doing a whole lot of pure biology in here, right? I expect you to kind of understand, you know, what a chromosome is, all that kind of stuff, DNA and RNA, but yeah. All right, who else?
I am here to learn because I am interested.
All right, look at that. A pure of heart reason. Some things showing up in chat here. Med school is daunting and computers are cool. Yes, yes to both.
Nah.
All right, how about you, Ernie?
I'm here to learn. Just like, who said he's here to learn then? And I wanna do a bioinformatics undergrad. So.
Gotcha.
Yeah.
Did you just wake up, by the way?
Me? Yeah, you were my alarm.
Gotcha. Yeah.
Was ringing.
You look a bit tired. Sorry about that. We're all gonna have to be on our toes to be here at 8:30 in the morning, and it's a rough thing to wake up and start looking at a command line. But we'll get it. We'll get it. All right. Well, let me just briefly show you our command line before we get into assignment 1 or get you downloading stuff. I just kind of want to show you what you're up against. All right, so this is your computer's terminal. If you're in Windows, Mac, or Linux, you'll have something similar to this, and we'll get into how to find it here briefly. But this is where you can actually talk to your computer using text. And it looks kind of boring, but it is without a doubt the most powerful part of your computer, and it's how we're going to access data and work with it in very powerful ways. So let me show you a few commands. I can just type in ls, and it's going to list all the files where I am. Okay, so I'm in my home directory right now. That's great, showing me some stuff. And if I want to get to my desktop, don't worry about memorizing these commands right now. I can say cd for change directory and type in desk, hit tab, it'll autocomplete for me, and I'm now in my desktop. I can check that by typing pwd, and it says, yep, I've printed your working directory, you are in your desktop. So now if I look around with ls, I see different stuff. I'm going to navigate real quick to where this course is located on my computer, and that's in my Git repositories for this website, then data skills. I'm going to look around in there. You can see we've got assignments, case studies, some data, media, practice stuff. Okay, and then this is our website. It's living on my computer and on the server when you go to it. All right, so I can update it on my computer and it gets pushed to the server. All right, so I'm going to go into data. Let's see here. And I'm going to take a look at this one little file here by saying g unzip chapter 7 practice file 1.fa.gz. Now look at it, it's been unzipped. It's 20 megabytes. So I'm just going to take a look at it. All right, this is what we're going to be dealing with pretty much all semester. We're looking at raw sequencing data. Okay, this is kind of in its simplest form, but it's obnoxious. I look at this and my toes curl, right? It's a nasty amount of data, 20 megabytes of this, and that's a very tiny file. I made it small so that we can work with it quickly. All right. What are your thoughts on this? We can share our feelings. It's okay.
I'm excited.
Oh, we gotten excited?
Yes.
I have sort of an unrelated question. What is the difference between command line and command prompt?
Nothing.
Okay.
Yeah. You're on a Windows computer?
Yep.
Oh, there is a difference then, and we'll get you sorted.
Okay.
Yeah. All right. So this is just one file. When you get back sequencing data from a sequencing center, like you send it out for Illumina sequencing, some samples or whatever, you can get back hundreds of files that are all 100 megabytes large of nothing but this. And so without data skills, you're basically hamstrung at that point. There's nowhere to go. Human brains can't process this kind of information. The amount of time it would take, your great-grandkids would be dead before you'd read through one of these files, okay? It's just not going to happen. And so the kind of skills we're going to learn in here is basically how to manipulate these raw files, use quick little tricks for looking for things. Okay, so let's say that I was looking for a particular sequence, like GCTTAACACA-TGC, right? Why might we want to find that in a biological setting?
You're looking for bookmarks or for any kind of identification piece for that, whatever you're sequencing.
Yeah, it could be a sequence that we know is associated with a certain species that we're looking for. If we had like environmental DNA. What else?
The balance of GAT or ratio.
Yeah, so looking for whether something is CG rich or AT rich. What if you're researching the coronavirus? You're an epidemiologist and you've heard about a new strain from England that's already spreading around the world, hypothetically. Okay, maybe you know the sequence associated with that new strain and you're looking for it in your patients. Okay, now there's no need to spend literally tens of thousands of dollars a year for point and click software that can help you find that and do it slowly. Right, we can actually just use a little program, grep, where we look for that pattern inside of chapter 7 practice file 1 FASTA. We find all the times that it's in there. If I want to see what species it came from, I can say, give me the line before each time you found that as well. All right, and so we're finding it. There's our species. There's the pattern of interest. Okay, it searched 20 megabytes in a second printed it to my screen. Okay, I can send that to a file, have it go right into an analysis pipeline that I'm working with, something like that. Okay, so we're essentially just going to be learning how to do this sort of thing. It's not too hard. You can have a cheat sheet. We got shared notes, you got a book, you got the internet, but it's a lot to learn. And the cognitive load here is different than in other biology classes you probably had, because we're talking to a computer. Computers are really stupid. They take everything literally. It's not going to know that I meant chapter 7 practice file 1.fa if I use a lowercase c there. I hit enter there, it says nope, no such file or directory. Okay. The computer can't read your mind, and so everything has to be kind of perfect as you type it, which leads us to doing a lot of copy pasting because it reduces typing errors. And so we've got a whole channel on here kind of dedicated to that, this troubleshooting channel. So make use of that. Okay. We can all collaborate on stuff together in the troubleshooting. All right. So I just wanted to show you command line, get that initial shock out of the way. For those of you who are like, this fits into my schedule, not really sure what I'm getting into, this is it. This is what we're doing. It's incredibly powerful, and talk about an awesome career skill. This will get you a job, whereas knowing the different types of butterflies will not get you a job. Okay, so that's what we're going for here. All right, so get your book ordered, get that website bookmarked, and I might as well show you assignment 1. So if you click on that, this one's real short. We're going to have you read chapter 1, pay attention to some things, and then write an essay. Yeah. I want you to kind of get into your headspace and show me what you're thinking about. Really consider why it is you want to learn bioinformatics. If that's, just a career move, if you're just interested, but something to do is probably not a good enough reason, because, well, you just saw what I saw, right? It's kind of a nightmare. So I want you to think about why you want to learn bioinformatics. Give me a little essay, and then your plan of attack, what your strategy is going to be this semester for actually making it here at 8:30, doing your practice problems and getting stuff done and learning. Okay, that is due Friday at midnight. Okay. Now, as far as computers go, give me a little hand raise if you're on Windows. 1, 2. I can't actually see all of your faces, so maybe give me a digital hand raise. 4. Okay, so about half. That's all right. Windows doesn't have kind of this built-in command line prompt in the same way that Mac does. Okay, and so we're going to have to download something. So get to your Google search and type in git bash Windows. All right, and this is the one you want here. This git scm downloads git. I'll paste this in the chat. Okay, so it's in our chat bar. go ahead and download and install that, and pretty much you're done at that point. You're kind of good to go for the bulk of this class. There may be some software that we use later in the semester that literally won't work with a Windows architecture. So for that, we've got some virtual machines set up. So you just get into the university's system and log in, and it basically will pretend that you're working on a Linux machine. Okay. But this is the download you want. Windows, the 64-bit. Get it installed and you're good to go. Stick that somewhere easy to find on your desktop, because when I say open your terminal, that's what you'll click on if you're a Windows user. If you're Mac, I believe the shortcut is Command-Alt-T, or just go to your Finder and type in terminal, and it'll find it for you. All right, questions so far? Trevor, you still have your hand up. Is that purposeful? Oh, okay. Seriously, no questions? Maybe I'll just give you a second to download and install this.
It's just Command-T on Mac.
Command-T?
Yep.
Okay, that's good to know. The fact that we're all on different operating systems is kind of annoying, but we'll be okay. This book was written by a Mac user. Everything in it works really well on Mac or Linux, but there may be a thing or two that Windows just doesn't like. This is changing rapidly. Windows is becoming more Unix friendly, and the prediction is that within the next 5 years, Windows will actually be Linux, just kind of running a shell on top of it. And so things are going to be getting easier for Windows users. You'll just be paying a ton of extra money to be running the free Linux. All right. I am a Linux user. That happened in grad school when I had to do bioinformatics without any instruction. Just kind of was thrown into the deep end using my Windows computer and found some things that just wouldn't work for. And so I just switched over to Linux, and that's where I've stayed ever since. What I like about it is that it's free and it does all the same stuff, and for scientific computing, can't be beat. But for this class, you're going to be fine on Windows. If there's anything we run into, we can get you signed up on that virtual machine, get it working. Trevor asks, what version of Linux do you use? I like Ubuntu because it's kind of the most user-friendly. In my experience, it's got the most support out there. If there's ever a problem that I run into, I can Google it and somebody's solved it 100% of the time. There's something I can copy and paste into my command line and it fixes the problem. All right. Now give me a raised hand if you have your terminal open. We're going to work together in real time, trying some stuff. All right, there are a few of you that don't have it. Can I help in any way?
Once you've downloaded it, how do you open your terminal?
It'll be an icon probably on your desktop or in your downloads that's just git bash, or like git for Windows. Just double click that and it'll bring it up. It'll bring up something that kind of looks like this. My dog just threw up twice right behind me. And now he's eating his puke. So
I was gonna say, if you wait long enough, it'll probably be gone by the time you look back.
yeah, I just have to hear it. So do you. Ah, nice move, buddy. Sabrina, have you found? You've got it downloaded, right? The
Yeah, I'm trying to install it again because it's not giving me like a little icon.
okay. You may have to search for it. It kind of depends on where your computer is sticking things. Oh, that's nasty.
Okay, I got it.
Got it? All right. Yeah, so get that opened up. And the first command we're going to learn, we're going to go ahead and just get into this. To get you used to typing, please forgive the disgusting sounds of a dog eating vomit in the background. PWD. All right, so I'll make this bigger so it's easier to see. Type that in and hit enter. All right, what do you see?
C-users-1091-3084.
All right. Copy that and paste it into the chat, everybody. The result of the PWD. Is this what's happening to you when you try to copy it? It's tricky. All right, so I'm going to double click on that. If you double click on a line in your terminal, it'll highlight the whole line, even if it wraps around like this one's doing. And for me, it's Control-Shift-C is copy. Okay. And Control-Shift-V is paste in the terminal. You can also just go up here to edit, and it's got copy and paste, and it'll tell you what your hotkey is. Okay. So Control-Shift-C, and then I'll paste it with the normal Control-V here in our chat. So that's what I've got. Okay. Everybody's looking good. Now, Sabrina, yours is a bit different than all the rest. Who can help me identify what's different about hers?
The space.
There's a space, okay? Windows is totally fine with spaces and file names, but your terminal isn't. It really doesn't like spaces and file names whatsoever. You can do it, you can get around it, but it takes some finagling, so to speak. From now on, you are all members of a new religion, and that religion is no spaces and file names. Okay? Treat it dogmatically. So for the rest of your life, you no longer put spaces in file names. You'll see why. But Sabrina, I just want you to be aware of that part of your file path actually has a space in it. And so using tab to autocomplete will be really helpful there. Just keep that in mind. All right. So that was PWD. I want you to remember that one. Now I want you to do CD and just hit enter. Okay. that takes you home. This is your shortcut to go home. CD with nothing after it is just change directory, and by default it takes you home. That's probably where you already were. To find out if you've changed location, you just type in pwd again. Okay. That's print working directory. Think of pwd as kind of just asking your computer, where am I? Right? If we've got a file browser like this, it's kind of easy to see where you are. Right? I'm in home, desktop, we've got Git repositories here, bioinformatic data scale files. Okay, so you kind of see where you are. Since we're just using text, pwd is, hey, where am I? And cd is, I want to go somewhere. Okay. Your next one is ls, just short for list. That's going to list everything that's in your current directory. I got a bunch of stuff. What kinds of things are you seeing in your home directory? It's been a while since I've been on Windows, so I don't remember the default structure. Might be desktop, maybe like videos or documents, that kind of stuff. I would like you to navigate to your desktop. Okay. So for me, since I'm currently in my home directory, when I say pwd, it says you're in home gzon. Okay. And then when I type in ls, it shows me desktop. That means I can go there from here. That's a door that's available for me to open. So I would just say cd desktop. All right, quick, somebody help me. What do I type to figure out where I am?
pwd.
pwd. And I'm in desktop. All right, when you get into desktop, please copy and paste that file path into the chat. Noah, yours looks weird, but okay.
What about it's weird?
It's got that little tilde.
Yeah, all of mine have
space.
had that
Okay.
so far.
The little tilde thing, the swirly,
Mhm.
is shortcut for home. So anywhere on your computer, you can say cd tilde, and that just means home.
Okay.
And so I think yours is just displaying kind of different, but that's all right. And then Sabrina, your desktop is lowercase. Okay. That'll work. All right, what do I type to list all the files in my desktop?
ls.
ls. Okay. Here's all my desktop files. Try it on yours. Are you seeing things that make sense that actually are, for example, on your desktop? So if I open my little file browser and go to desktop, I should see the same stuff in here that I get here, just a text version. Okay, anyone having trouble so far? If you are having trouble, please speak up. It's having trouble in this class is not a bad thing by any stretch. We're all going to have trouble at some point. If you're not failing, you're doing it wrong. Okay. So here I am. I want you to pick a folder on your desktop and navigate into it. While you're doing that, let me show you a little trick. Your tab key is an autocomplete. So it'll try to figure out what you're trying to type in terms of file names. And if you type in the first letter or two or whatever, it's going to take you there by hitting tab. So if you watch my screen, I say cd git in all caps, hit tab, and it autocompletes because there wasn't any other file or folder in my current directory that started with git like that. So that can be really helpful. You'll wind up using tab quite a bit in this class, and it's actually better than typing because it's not going to spell things wrong. All right, so I've navigated to some directory in my desktop. I'm going to say pwd, where am I? And the file path grows. Copy and paste that into the chat.
So mine keeps saying it's not a directory.
All right. When you
Mine's doing the same thing.
so you do cd and try typing, and it says not a directory.
Yeah.
Yeah.
All right. How about real quick, Caleb and then Sabrina, share your screen with me.
Let's see. Are you able to see that?
It's coming up. Okay. All right, I see Sabrina's now. Okay, type in ls. Sabrina. Okay, so you don't have any directories. You must have the cleanest desktop of all time. That's amazing. All right, so the directories will show up in blue, it looks like, on your computer. You can see kind of up towards the top of your screen, there's like desktop documents, downloads with that backslash.
Mm-hmm.
That's a directory. So you actually don't have any directories on your desktop. Okay. And I see the reason why is because you have two desktops, one lowercase and one uppercase. And you need to be in the uppercase version. So type in cd space ... just two periods. ... means go back one. It's kind of our backup Okay, dot dot refers to the previous directory. All right, so now type in ls, enter. Okay, now cd space desktop with a capital D, and try to hit tab there. Okay. Enter. Okay, now an ls. Still nothing. You have a nice clean desktop.
Thank you, thank you.
All right. I'm going to share my screen with you again, so you can go ahead and close out your sharing. And it's as good a time as any to learn a new command. So cd dot dot backs me up, so I'm in my desktop now. I can look around, I see all this stuff, but I want a new directory so I can go into it. What do you think mkdir stands for?
Make directory.
You're amazing. Yes, it's make directory, and so you can give this any name. All right. So I'm going to say new directory. Womp womp womp. What did I do?
No spaces, please.
No space. So I'm going to back up. Instead of a space, put a little underscore. Okay. So I'm making new directory. mkdir, make directory. I list this, and there it is. Turns up. In fact, if I go into my little file browser, I can go to desktop, and there's new directory. So made it in my command line. My computer recognizes it. It shows up. So now I'm going to go into it. I'm going to say cd new tab. Yep, that completed. New directory. pwd. Copy and paste that if you can remember how. Good. All right.
Mine said that that command was not found to make the new directory.
I'm betting you spelled it wrong. Share your screen with me. I want to
Okay.
see what you're seeing.
Can you see that?
It's popping up now. Okay. Yep. mkdir.
Wait, I'm
Go ahead
typing the
and-
wrong thing. MKDR.
Space, then the name of your new directory.
And then what's the next step after that?
To go into that new directory and do ls or pwd to show the path, print working directory, and then paste that into your chat. Okay, so Noah, now you need to go into it. So that's cd for change directory. So cd space new directory.
Oh,
What happened?
I have no idea.
Hit Control C. Okay. Control C is your stop everything. I've made a mistake button.
Gotcha.
All right. So yeah, just type in CD and then Shift Insert. Well, after a space is your paste. Or just try typing. Actually, I prefer you to do the tab thing. So type in capital N EW and hit tab.
Ooh.
Yeah, because you spelled it direct Roy.
Oh, jeez.
That's all right. Tab didn't care. Tab auto-completed
Okay.
it. Okay, so now you're in new directory. Do pwd and paste that output into our chat. Yeah. Okay, we got testing new directory, new dir, new directory, new directory, new directory. Okay. We're in a safe place now in your computer. Something where there are no files that you can mess up. So that's nice. But before we get to messing with files, I want to talk about these things we've been pasting in. These are called file paths. And it's really, really an important concept. Every file on your computer lives somewhere, and it has an address. Every directory on your computer has an address. They're all sitting within some folder. So you can think of this as folders within folders within folders. Those can have files or other folders in them. This is the directions to get there. Let me share again. All right, so this right here is from how to go from the very root of my computer where the operating system lives and all that kind of stuff. How to go from there to some file or some directory. So this path starts with a little backslash. That means root. Okay. That's as deep as you can go in your computer. It's the container that holds everything in your machine. In that root live a bunch of directories, most of which you should probably never touch until you get really good at this. Okay. If I say cd backslash like that, it's going to take me to my root. Don't do this, but I'm going to show you what's in there. It's going to be different on your computer, okay? But it's stuff like the mounted media. So if you have any thumb drives in there, these pop up here. If you still have CD-ROM, that's just kind of a holdover, old school. Your boot directory, that's where your computer goes when you first hit the power button. Bin is something that we actually will deal with. This is where programs live, okay? And then there's these libraries, and those are big chunks of code that your computer programs have to utilize. Okay. So all that stuff lives here in root, and if I say pwd, it says, okay, there you are. You are in your root directory. Okay. So typically I don't want to be there. I kind of want to start from home because the stuff that lives in your root directory tends to be stuff that's really important for your computer functioning right, and so we don't want to mess around with stuff until later in the class, but we'll probably get virtual machines set up so if you destroy something it won't actually hurt your computer. Okay. So I'm going to say cd home, and then I can look around there. There's only one thing living in home, since there's only one user on this computer, and that's gzon. So I can say cd gzon. You see how my file path is growing with each subsequent folder that I go into. Gzon lives inside of home, which lives inside of my root. And desktop lives inside of gzon, which lives inside of home, which lives inside of root. Okay. This seems like a very simple thing, but it's hard for me to overstate how important it is that you understand the file path, kind of the structure. everything we do in here will be talking about files or running programs. That program lives somewhere on your computer. That file lives somewhere else. And so we're going to have to tell your computer, here's the program I want. Here's where to find it. I want you to use it on this file. Here's where to find it. And so we'll do that by using these paths. Okay. So that file path just grows and grows the deeper you get into your computer. Right? We started out in the big bin, and we're becoming selectively more exclusive in the files we're looking at. All right, it's time in that programming class that every programming class starts with, your first program. It's real easy. We're going to say echo.
The world.
Hello world. Put that in quotes. Let me know if that doesn't work for you. What it should do is just print out hello world. It'll print out anything that's between those quotes. Echo, you suck. Boom. All right. So echo is a program. It lives somewhere in your computer. The which command will try to find programs for you. And so if I said which echo, it said, oh, there it is. So that's the directions to echo. Okay. I just wanted to point that out. This is a program. It's echo. It's a program that actually lives somewhere on your computer, and its function is simply to take things inside of quotes and send them to your terminal. What good is that? By itself, I mean, not much. If you had a more, like a longer script, say, that was doing some bioinformatics work, chaining a few things together, you may want to have it, because it's working in the background, you may want to have it tell the user something like, oh, now we're binning our contigs. Okay. Oh, now we're aligning sequences. So the echo can be used for that kind of situation to give like user feedback during a program. But by itself, it's not super useful. So I'm going to say hello world, echo hello world. Time for your next little shortcut, kind of like tab. This is the up arrow. The up arrow will cycle through your previous commands that you've entered. Same with, so up, 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 down, down, down. Super time saver here. So I'm going to just hit up to get back to echo hello world. I can do that over and over. Only this time, I'm going to add something. I'm going to throw a little space in there and put a greater than symbol. I'm going to send it to new file. Okay, let me walk through what this is doing. Echo's a program. It takes anything in quotes and it sends them to output. By default, that output is your computer screen. But we've thrown it a curveball and we've said, I want you to redirect your output. Instead of showing it to my screen, I want you to send it to new file. So now when I type in ls in my new directory, I've got something brand new, new file. All right, so after you run this, it should have created a new file for you. I found it with ls right there. So I'm in my new directory in my desktop, and inside of that directory is something called new file. Who doesn't have that? I see a couple hands. Are those left over? Ernie and Trevor.
I have a question.
Great.
But when I do the exclamation mark, I get this message right here when using echo.
Oh, yeah, that's a Mac thing. Skip the exclamation mark. It's all right.
Yeah.
I think you can get away with that if you do like an escape character.
Oh, okay.
Mine's interpreting it literally, so you may also have to do single quote strings, but I would say just avoid the exclamation mark for now.
Okay.
Okay. So if you type in ls, you should see new file. That's a file. What's in it? Any guesses?
Hello world.
It should be. It should just be a file containing the text hello world. I'm going to go in here, desktop, new directory. Look, there's my new file. Double click on that, and sure enough, it's just the text hello world. Now that takes a lot of time, and if you're dealing with thousands of files like you will be in a bioinformatics project, you don't want to double click on them all. Okay. So we have another command. It's just cat. Now this is actually short for concatenate, sticking things together, but I like to think of it as a cat barfing up a bunch of stuff. So cat takes the contents of a file and pukes it up on your screen, kind of like my dog, who only ate one of his vomit piles, by the way. That's awesome. So if I say cat new and then hit tab, it'll autocomplete for new file. So cat new file, hit enter, and it's gonna show me the contents of that file. Hello world. Well, we're about halfway done with the semester in terms of the programs we're using. We got pwd, ls, cat, cd, make directory. Right? We've already covered 5 new programs that you've learned how to use. These haven't changed since 1964. Right? People are still using them. They're that good because we can chain them together to do stuff. Right? Bioinformatics software changes every year. Right? The stuff I was using 2 years ago is not the same programs I'm using now. Okay, so learning specific software like that is probably not the best approach for learning bioinformatics, but they all of them work on through the command line, and they work with this same kind of idea, and that is your bash terminal here has a bunch of little crappy programs that kind of suck by themselves, like cat or like echo, but you can chain them together in really interesting ways to accomplish difficult things. Each of these programs does one thing. It does it really well and really fast. And they all have the same underlying kind of structure, and that is they're text-based. So we've got a stream of text going into the program, and it gives us a stream of text out. At its simplest, that's what we're dealing with here. And so the program cat hello world, or cat new file, took the contents of that file and streamed it to our interface, our little terminal here that we're looking at on the screen. Okay. Same thing for echo. Echo just looks for stuff that's in quotes and sends it to the terminal by default. Okay. Up here, we redirected that. And so we said, instead of coming to the terminal screen for me, the human, I'd like it to go to a file. All right. That's a really powerful concept. It may not seem like it right now, but we can split this data up, right? We can take our giant FASTA file full of sequence data, read it into a program, have it do something, send the intermediate stuff to a file, and then send the final results to a second file if they work. Okay, and it takes seconds, and it's really kind of a short program like this. If you remember, we did that grep thing. So I'm going to go back to where our assignments live. I'm going to do this old file again. I'm going to cat chapter 7 practice file 1.fa back again, and there it is. Well, that's not very useful. Okay, but if I hit the up key, it'll bring that back up. I can do this little pipe, which means instead of sending it to my terminal, I'm going to send it to another program. So I'm going to send that to grep and look for anything that has that sequence of A. Ah, there was nothing. I'll shorten it a bit. Okay, there's a few. I'm going to say, hey, give me the line before also. And then I'm going to send that to new file. Okay, so I took cat grep, a redirect to file, and a redirect to program. And right there, this is pretty powerful. I was able to search this giant file for this particular sequence, find it, and send just those sequences to a new file. So I look around, I've got new file right there. I can cat new file, and I've saved all the species that had that sequence.
What does grep do?
It looks for things inside of a file. We're not going to cover it in much detail yet, but you're going to love it. I actually promise. Like, it's super, super useful. It's generalized, or I think it's global regular expression pattern. And so it just matches patterns within a file or within some text. Regular expressions are their own programming language. They're really hard to learn, but basic, simple stuff like we just did is usually as deep as you need to go for looking at bioinformatics stuff. We're looking for patterns in DNA sequence. Okay.
And what does the vertical line do?
The vertical line is a redirect. But instead of redirecting to a file, it redirects to a new program. We're going to cover it in great detail next class period. Okay. So I took the output of this program cat and sent it to a new program, grep. So we can chain these little short programs together with this vertical line we call a pipe. We can chain a bunch of stuff together to get really interesting results quite quickly. Just as an example, don't worry too much if you don't know what's going on here. I'm going to add another pipe just to kind of show you. And of the things that I found 7 A's in a row, I can say grep starts with the greater than symbol. So I'm going to just be trying to find the lines that have the names of our species and send that to new file. So now when I cat new file, it's literally just a list of the species in that file that had that particular DNA sequence.
Okay, can you copy that line that you just typed in into the chat?
Yeah. With a caveat. It's got a bit of a slightly dangerous thing in it. This right here, don't take those quotes out accidentally, because it'll treat it as a redirect there. And so you can overwrite files on accident. So run it as is. By the end of next week, all of you are going to be pretty strong at doing something like this. It's really not too difficult. The foundation of it, though, is that we need to know those file paths. We need to understand that each one of these little programs is just doing one thing, so we can stick them together. Okay. This one barfs up the contents of a file. This one searches for that pattern and includes the line before it found that pattern. And then this one searches for lines that start with or greater than. And that was just the pattern here in this FASTA file. I could go even further and say sort and then unique. So I can keep changing the output here. And so this way I get a unique list of all the species. No duplicates that were found in that file. Okay. Now, we've got about 6-7 minutes left, so I'll close up with the most dangerous command that you need to be very careful about typing, and that's rm. Don't type this into your computer. Don't do it. Not yet. We are not there, my Padawans. RM is remove, and it's for keeps. It does not go to like a nice recycling bin or a trash that you can empty later. It is instantly gone forever, okay? Maybe the FBI could get it off your computer with some like forensic skills. Maybe. It's gone. So if I say rm new file, that's it. New file is now gone. Okay. So I'm just doing that to kind of clean up my directory here. I don't want a bunch of junk in there. And then this one, I'm going to put back into its compressed gzip form. All right, so that's the way we found it. Okay. I'm going to do cd ... to go back one. So now I'm in BIMF data skills. cd ... again. What will this give me? .. /..
Does it just keep you there?
Nope.
Goes back to get repositories.
Yeah, it's a file path. This first 2 ... pair is the directory before where I am. Here's where I am. So that's going to go back one to here. And then it's going to go back another one to get repositories. So if I hit enter here and then pwd get repositories, it's pretty cool. So we can make file paths like that, basically moving around our computer with great speed. Okay. Next class period, we're going to set up some aliases that make things even faster for you. Aliases are just short ways of typing something difficult. So for instance, something I do very often in bioinformatics is turn what's called a FASTQ file into FASTA. These are DNA sequence files. I do not want to have to type that every time. And so I made an alias, FQ to FA. I can just type that and it's good to go. Another one that I use an awful lot is U. That clears my screen, goes back one directory, prints the working directory, and then lists everything. So if I type U, enter, I go up one and it lists everything just right where I am. If I type D, it goes back down to where I just was. I'm going to get you those aliases in next class period. It's like an up and down. It's really easy to move around. But you do need to be able to use CD. Okay. So this is it. This is our class. The cognitive load right now is pretty high. I get that. So we're going to move very slowly at first. But you'll be amazed at how quickly you're able to do really powerful stuff. In 2-3 weeks, you're going to be light years ahead of your fellow students in terms of like DNA analysis, just by getting grep, sed, ls, cd, getting those to where they're kind of muscle memory. Okay. So with that in mind, we've got practice here. Watch those videos. We've got an intro to Linux. That's for you if you're on a Mac and if you're on Windows, because it's actually an introduction to Unix, so the command line, what we're doing. Here's your link to download Get, but it looks like all of you got that unless you weren't here in class today. We've got a repository that goes along with this textbook. So sometimes there's examples in here that require files. He's made those available to us, so we can go to that repository. And then a refresher video on navigating your terminal. That's the CD, PWD, LS, that kind of stuff. I want you to spend an hour, I'm not kidding, just moving around in your terminal, listing files, asking where you are, doing CD ... practice the ... /... Get to where that's second nature, and this class is going to be a whole lot easier than it might seem. Okay. We're looking at this, and it looks like gobbledygook. It's text, it's scary, right? But in reality, there's probably only like 50 commands that we're going to learn in this entire class. At most. It's going to be up to us to put them together creatively to accomplish really cool stuff. And so that's what we're going to be spending our time with, is like learning how to put these things together, seeing what's available. If you type something and you can't remember what you typed, don't forget your up key will cycle through your last files. And there's also a little command called history, and that is literally just a history of the stuff that you've typed in this bash terminal. Okay. It doesn't go on forever, but at least the last couple thousand it'll have. All right. So those can be helpful. CD by itself does what? Pop quiz?
Change directory.
Home directory. Yep, that takes you home. So if you're lost somewhere, this happens, you're like, where am I? It says file not found, but I don't know where I am. Just CD, boom, start over, navigate around. Okay. Do assignment 1. Give me that essay by Friday. The first chapter is going to really walk through why we use bash, why we use the command line terminal for bioinformatics. Like, you know, this is 2021. Shouldn't we be having holograms and waving stuff around like Star Trek? No, this is actually more powerful. I swear. Like, there's a reason that for the past 80 years, this is what people have been doing. Okay. So with that, we are out of time. I'll stick around if anyone has questions. So I can stick around 5-10 minutes, but otherwise you're free to go.
We need those self-lacing shoes.
What's that?
I self-lacing.
I know. I've like
Hey, Zon, can you look at my screen real quick?
Yeah, share it.
So it's only these files that are lit up like that that actually have stuff in them.
Yeah.
Okay.
Those are your dark blue ones that end in a backslash. Those are directories.
Got you. Okay.
The things with an @ after them are like short links. So they link to a file that's actually somewhere else, or a directory that's somewhere else. This is Windows, right?
Yeah.
And I'm assuming that you've got like the cloud, Microsoft Cloud, whatever.
No, I just
Okay.
clean up my files pretty regularly.
Okay. A lot of times people using Windows that have that cloud, it's actually stored online, not exactly on your desktop, and so things can get a bit weird with that.
Okay.
I discourage that use, but
Well, I don't think I keep anything on my actual desktop.
okay. As we start getting materials for this class, I would encourage you to have a file or a folder on your desktop that's just
Okay.
this class.
Okay, sounds good.
Because it's easy to access that way, and you don't have to type big long file paths to get to stuff. But
Okay, cool.
yeah,
Yeah.
but yeah, everything looks good there. You've got some temporary files, you've got some short links, but the dark blue / directory.
Okay.
Yeah. All right. Anyone else have anything?
I've got for the class, do we have to download a data course? And
Not yet.
oh, not yet. Okay.
Yeah. We're gonna get comfy working the command line long before we start downloading big files and like all the data files from the textbook and all that kind of stuff. Yeah, you're going to be downloading a lot of stuff in this class. We've got a pretty fun one, I think. One of the assignments will be coronavirus genome. We're looking at the new variants and all that kind of stuff, reproducibly downloading that, and so it can get kind of big. So you're going to want some storage space on your computer. If you got like, 2 gigabytes left, maybe it's time to clean up some of those old songs you never listened to, because we're going to have some data for sure.
Thanks.
But before it gets too bad, because I realize we're all on laptops, to do like a metagenome assembly, that's just going to burn your laptop to the ground. It's not going to happen. So we'll push that. We've got accounts coming for all of you at the U of U's supercomputer, and so we can do stuff on there also. Yeah.
Cool.
All right.
Sorry,
Yeah.
I have a quick question. So I'm on my like work laptop, and it has like the cloud stuff that you're talking about. It's like I don't have a desktop directory.
Okay.
And like I know it doesn't really matter. Like I can just put the files elsewhere, but like it doesn't seem like it's complete. When I list stuff and like there's just like 10 different file paths for stuff, it just is super confusing. Do you have a recommendation for where I can do things?
Put something in the home directory that's just for this class.
Okay.
Like in lieu of a desktop, and that'll work.
All right.
You don't want Microsoft Cloud to know about this thing.
Okay.
They try their best. Bless their hearts. They do a good job for like casual computer users, but Microsoft really gets in the way of bioinformatics, and so you don't want their cloud to know about stuff.
Okay. So I'm on my work computer right now, but I do have a Mac at home. So I'm wondering if it would just be easier if I just use that instead.
Yes.
Okay. Fair enough.
The reason is Macs are like natively fine for bioinformatics. You won't have as many workarounds, and you won't have to worry about that weird cloud.
Okay.
Yeah.
Okay, thanks.
Cool. All right. See you all next class period.
Yeah.
Real quick, I have a quick question. I'm
Yeah.
not able to find that website to the class. Could you just send it real quick so I can
I'll post
access
it here. Yeah. I stuck it in our general chat, but it may have gone like way up. All right, there it should be in our chat.
Perfect. Thank you.
Yep. See you next time.